Special relativity is not obvious. It's a little bit counterintuitive. We could use the word weird. It's different. So instead of just jumping in, telling you exactly what special relativity is, we're going to take a bit of a scenic route to get to what it is, to try and make it more intuitive. Basically, what special relativity does is we're going to rethink, instead of thinking of space and time as separate things, we're going to think about them more as basically one entity. So to get there, let's suppose we had two cars, and these two cars are exactly the same. They're going to have a race, a very, very simple race. They're just going to start at a starting line and drive towards a finish line, and whoever crosses the finish line first, that car wins the race. Since they're identical, they go at the exact same speed. What would have to happen for one of these cars to win the race? What if I told you nothing mechanical, like not like a car breaks down or anything weird? The cars are exactly the same and they're going the exact same speed, but what if I tell you that one of them crosses the finish line before the other? One wins the race. Think about it a little bit. Could you think of a way that that could happen? All right, scrolling down. There are, and I usually, in a normal world, I got to be careful using that phrase too often. If we brainstormed it, there's lots of possible answers. And for a while, I would actually get out toy cars that were exactly the same and have you go through races and see if you could discover it. But out of the many possible answers, the one that I'm aiming for, the one that's going to help us understand special relativity, what if one of the drivers goofed up and went on a bit of an angle? So the way I've drawn it, let's say what I'm calling car 2, what if car 2 goofed? Maybe they're a new race car driver and they goofed and they went on a bit of an uphill angle. Not so much that the cars crash into each other, but just a little bit of an uphill angle. If these cars are exactly the same and are going the exact same speed, but car 2 goofs and goes on a bit of an angle, who loses a race? And just as, or more important than who loses a race, can you use your words? Can you articulate why car 2 is going to lose the race? Again, if we took time in person to talk about it, I get lots of explanations that are all correct, but the one that helps the most for where we're headed is to think about components. If the cars are identical and drive at the exact same speed, car 2 loses the race because it took its velocity and it shared it between the two components. Some of its velocity was perpendicular to the finish line, meaning that the velocity that's pointed towards the finish line is a little bit smaller. The steeper the angle that car 2 goes on, even the steeper it goes, more and more and more of the velocity would be perpendicular, which means less and less and less would be towards the finish line, which would mean it loses by even more and more and more. So bottom line is, the more car 2 travels in that perpendicular direction, the slower it travels towards the finish line. Since car 1 is traveling completely towards the finish line, all of its velocity is pointing towards the finish line, it's going to get to the finish line as fast as possible. Okay, file that away. I'm going to pause this video again too. We'll have lots of little videos. I borrowed this kind of analogy and this explanation from a really cool book called The Elegant Universe, written by a guy named Brian Greene. I've read the book. It's awesome. If you're not into reading, I couldn't find it for free, but PBS has turned it into a whole video series, which is also really good. If you're kind of keen on this modern, cutting edge new physics, if you're looking for more, maybe look into the book Elegant Universe or see if you can find a copy of the video series.